Hello everyone. So today SQL and NoSQL bit of. I'm going to add one more video to this complete session so as to make you people understand better.
Hello everyone and welcome back. Today I'm going to talk to you about the difference between SQL and NoSQL databases. I'm going to start out by defining what SQL and NoSQL is, followed by some general guidelines on how to pick one over the other when starting a new project. So let's start out by defining what SQL is. So SQL stands for Structured Query Language, and the language typically looks like what we have on the right here. So SQL allows you to perform some create, read, update, or delete, also known as CRUD operations, through a universal language that is pretty much consistent across multiple different underlying relational database engines. So as I said, there's multiple different underlying relational database engines, and these typically are things like MySQL, Postgres, or Microsoft SQL Server. So there's four key components that I like to talk about databases. So there's structure, storage, scale, and access. So let's quickly go through these and talk about how it relates to SQL. So starting in the top left with structure, you typically interact with tables in a relational database engine. So as an example, we have an accounts table here, and a table consists of rows and columns. The columns correspond to the types, and the rows correspond to the individual entities that exist in the table. So we have an account ID here, we have a creation ID, and a country ID, and every row here is an entity or an element. So A1 is the account ID, it had a creation date of September 30th, and its country ID is number 1. Now in a SQL table, you must have a primary key, and a primary key corresponds to the unique identifier that identifies a specific row. So in this row's case, the primary key is A1. You have attributes that correspond to just general data about the record, and then you can also have things called foreign keys, which are links to other tables. Now SQL databases also enforce constraints. So for instance, down here, we're seeing that the account ID column is only allowed to be a variable character or a string. Similarly, the creation date is only allowed to be a date, and the country ID is only allowed to be an integer. These constraints make it such that if a user is trying to insert or update data, and the data violates the constraint that's imposed on the table, the operation will fail. So this is a great way to enforce consistency across the content of your tables. Thirdly, possibly the most important, is that we have relations. And let's just bring up a second image here that has a relationship. So in this table we have the accounts, which was what we originally had previously, and we saw that we had a country ID with this vague name here, so country ID 1. And separately over here we also have a country table that exists on its own, and in there are the identifiers for each of these country IDs. So country ID 1 corresponds to USA, 2 for Canada, 3 for Australia, so on and so forth. So what SQL databases allow us to do is build relationships. So we can say country ID 1 corresponds to USA, 2 to Canada, and 3 to Australia. What this allows us to do is perform some very flexible queries, such as give me all the accounts where the country ID is equal to USA. Now in terms of storage, the storage pattern is concentrated. So in a relational database engine, there's typically one node that contains an entire copy of your data. It's typically not partitioned or segregated in any way, unless you're using some advanced strategies. Now down to the bottom left, in terms of scale, there's two approaches here. So the first one is vertical. So if you have a machine that's hosting your database engine and you're suffering in the performance area, the option here is to build a better machine. So have more memory, get a better CPU, add a faster hard disk. These are ways to vertically scale your machine so that you can get better performance. Keep in mind here that there is a physical limitation in terms of how powerful a machine that you can make. So there is an upper ceiling on vertical scaling. The second approach is horizontal, which just means adding more machines. And when you add more machines in a horizontally scaled RDS environment, you typically perform that by distributing your data across multiple nodes. So in a horizontally scaled environment, you have one master, and then you have multiple read replicas. So when traffic is coming in, not only can that traffic read off of your master, but it can also read off of your read replicas. So what this allows you to do is to offload some of the pressure from the initial master node onto read replicas so that you can ensure optimal performance on your database. Now in terms of access, It's typically raw SQL, so writing the raw create, read, update, and delete syntax for your query. You typically require a direct database connection to the endpoint of the database, and typically these days people are using object relational mappers to construct their queries, and what these basically are abstractions that people use to add criteria to an object in a very programmatic way, and then allow that to generate a SQL statement that can be run against the engine. So we basically covered the 4 key pillars of SQL here, so let's move on to talking about what is NoSQL. So although it probably doesn't need to be said, it's anything that is non-relational. And there's many different implementations of NoSQL, so it's kind of an overloaded term. There's implementations that use table structures, similar to what we saw in the SQL approach. Some use document and some use graph. And the basic idea here is that NoSQL is built to scale with high performance, but it also comes at a cost, and that cost is that your queries are less flexible. So let's go through the same exercise as we did before and talk about the structure, storage, scale, and access. So in terms of structure, it is very implementation dependent. So as I said, there's table implementations, there's document implementations that store JSON objects under the hood, and there's also graph databases. So say for instance something like a Facebook social network where you have friends and those friends also have friends. A graph database is a perfect representation of that domain. The general theme among all of these is that they rely on key value stores. So generally in a NoSQL database, you need to know the key that you're looking for when you are performing your query. In terms of storage, it relies on hashing the input. So if you have a key that you're looking for, that key is given into a hashing function, and the result of that hashing function is a value, and that value is distributed onto one of multiple nodes. So say for instance if we had key 123, the key 123 would be inserted into the hashing function. The output would be a physical location on partition 1 where that data row is stored. And if you think about what this looks like from the read perspective, now the same kind of concept applies. So the same hashing function is run when the key is provided, and the engine knows exactly which partition to find the record on. In terms of scale, it's a very simple process, and that is to simply add more partitions. So instead of having the 2 partitions like we had in the top right, in this example we can just add 4 partitions and allow those individual partitions to scale individually. So add more disk storage, add more memory, add more CPU. Typically in a NoSQL database engine, all of this is managed for you, so you don't have to worry about the underlying details on how to add more partitions. Now moving on to access, there's 2 major flavors here. The first one is REST APIs, and you use REST APIs to hit a specific endpoint that has a certain functionality associated with it. Optionally, you can perform create, read, update, or delete in vendor-specific languages. So if you're using a vendor like DynamoDB, that will have a very different way to perform a query as something like MongoDB, which is another NoSQL option. So now that we know a little bit about SQL and NoSQL, let's move on to talking about when you should use what. So here we have a SQL and NoSQL table, so let's firstly go through why you would want to use SQL. So when your access patterns aren't defined, if you don't know how your business use case is going to evolve, and you're not sure if the way you're storing your data is going to allow you to query it in an effective way later, then using SQL is definitely the preferred option. Secondly, when you want to perform flexible queries, this kind of ties into the first point. If your access patterns aren't defined, you won't know what queries you're going to perform, so it's important to stay flexible so you can adapt to changing use cases. Third, when you want to perform relational queries. So this really is the bread and butter of SQL engines. If your domain is by definition relational and you want to perform queries that can make multiple hops among different tables, then SQL is the choice for you. Fourth, if you want to enforce field constraints, this allows you to normalize and keep your table consistent so that malformed data cannot make its way into your table. And lastly, for SQL, when you want to use a well-documented access language, SQL is generally universal across all the relational database engines that are underlying. So you can find a ton of support, and there's a ton of different communities that you can learn from to help you solve your problems. Now moving on to why you would want to use NoSQL. So when your access pattern is defined, so when you know exactly how you're going to be interacting with your database, it's definitely a time to consider NoSQL. Secondly, when your primary key is known. This is part of the limitations of NoSQL. As we were talking about before, the input to the hashing function is your primary key. So if you don't know your primary key, you're not necessarily going to be able to find the data that you're looking for. And thirdly, when your data model fits. As I was alluding to before, in a Facebook type domain where you have friends and they have friends, that's a very natural fit for a NoSQL graph-based database, so NoSQL may be a choice for you. And finally, the most important one, when you need high performance and low latency. This is where NoSQL shines. It can scale out horizontally pretty much infinitely while maintaining a consistent high performance and low latency. So now that we've done a little bit of a comparison here, let's walk through some example scenarios of when you would pick one or the other. So how to pick. So if you have a small project that's low scale with an unknown access patterns, you're better off using SQL. So if you're just starting out and you're not really sure if your product is going to take off and you don't necessarily know how it's going to be used, SQL definitely makes sense and is probably the best choice for you. And secondly, maybe you have a large project that is high scale that requires relational queries. I'd highly suggest using SQL, however, using a managed solution with read replicas so you can ensure high performance and consistency for all your customers. Now the main option here, since this is an AWS channel, is to use Amazon Aurora, which is a fully managed SQL database. They also have an alternative option called Amazon RDS that allows you to use a different underlying relational database engine such as MySQL, Postgres, Oracle, and others, and still gives you that managed functionality and allows you to have read replicas, monitoring, and everything else that goes along with a managed database engine. And if you have a medium or large project that is high scale and requires high performance, then NoSQL is definitely the choice for you. So there's typically two engines in the AWS ecosystem. There's DynamoDB, which is by far the most popular and most developed, and there's also MongoDB, and MongoDB has a canonical name, DocumentDB, in the AWS world. So if you're looking for Mongo on AWS, DocumentDB is the choice for you. Unfortunately, I can't recommend NoSQL for small projects. I think NoSQL is a better fit for those that have an established use case that require ultra-fast performance and high scaling abilities. So if you like this video, I have a great DynamoDB playlist that you should check out. Also, please don't forget to like and subscribe so you don't miss out.
Okay, so I hope you enjoyed that video and understood well. Now I'm going to play a video on MongoDB.
MongoDB, and we're looking at the good and bad of MongoDB, so we're trying to figure out whether or not this is going to be a good option for us. And really what we kind of compare is we look at whether or not MongoDB, being what it is it better than your traditional relational database that is like MySQL, Oracle, PostgreSQL, or any of those other relational databases. So first we need to look at what MongoDB is. Alright, so MongoDB is a database system that was created several years ago. The company was created by MongoDB Incorporated, and you can see it has a few founders that actually went ahead and built the company back in 2007, and they're out of Palo Alto, California, so Silicon Valley. And they have a lot of venture capital funding, and they've had a lot of help in being able to build this. It was originally built by Tengen, which is the name of the company before it became MongoDB Incorporated. And you can see it over here. So it's now been changed to MongoDB Incorporated. And just recently, MongoDB has actually released a new plan to be able to support more corporate database structures. So the bottom line is that MongoDB is and was created by a large company. The company's growing, and MongoDB is now being adopted by a lot of actual major websites out there, from sites that include like MTV, Foursquare, Forbes.com, and a bunch of other ones like the GE company, General Electric. So there's a lot of companies using MongoDB. So we're going to be looking at the good of MongoDB, like what are the good things about it. So number one, MongoDB makes it very, very much easier to actually scale your database out horizontally, which is also known as sharding. And MongoDB does that seamlessly, where you don't even have to bring your database down. You can just essentially add another MongoDB instance, and MongoDB actually handles load balancing between the two MongoDB instances that you have. And maybe you have 100 instances that are using across different servers. Well, MongoDB handles all of that complication for you. If you were using like a relational database like MySQL, it takes a lot of skill and expertise to be able to shard out as well using something like MySQL, where databases have to be in communication with each other as to what's being written to and being read from. And MongoDB just handles a lot of that out of the box, where you're not going to find that with MySQL. So if you're using one MySQL instance, and most websites are, but if you grow to become big and you have to have multiple MySQL databases on a cluster, things get very, very complicated. And MongoDB was made specifically to ease that sort of transition. So that is one part and one area where it does shine. So MongoDB is schemaless. So you have a database schema, which is your actual database design. So when you're in like MySQL, a traditional relational database, you're going to define your columns and tables. So you'll have like a music table, and then the music table will have columns like music artist, genre, location. So you have all that, the database table defined, and then you go ahead and build that table. However, everything you insert into that table has to follow the same schema. So it becomes very difficult when you have a MySQL database with millions of records, and then you want to add a new column to your database table. Let's just say you add a new column for a label, like a record label. Now you have this new column, and you have to update a million records with this new data, because you can't just have, maybe you have a column where the data can't be null, so you have a million invalid records in your database now. And that's known as database migration, where you end up having to take an existing database table and migrating it to a new database structure because your schema has changed. MongoDB doesn't have a schema, so you can just change your document type, and it's just going to work seamlessly without having to deal with fouling up a lot of your existing data that's in your MongoDB instance or database. All right, MongoDB is JavaScript for the most part. So JavaScript is JavaScript object notation. So JSON is the main data transfer language that you have among websites now. It's XML is still popular, but JSON is now probably the most popular with all the RESTful services out there. So the JSON data that is being returned by your MongoDB database can be used directly with client-side frameworks, JavaScript frameworks that deal with JSON data. So frameworks like React or Angular, they are all frameworks built around JSON for the most part. So dealing with JSON data and being able to build components in your website from that data. Well, MongoDB gives it back to you in the format that you need. So you don't have to do any sort of transition from getting a bunch of data from a typical relational database like MySQL and then having to serialize that into a valid JSON syntax and return it from the server. So that's one advantage of MongoDB, is that transaction is already in JSON format. That's a typo there, but MongoDB is NoSQL database, so it's not relational at all. So what that means is that and this is actually a good and a bad, because typically when you have a relational database, you can have several tables that are connected to each other. So you have like a person table, and then you have let's say a band table, and a band table could point to multiple person objects, right? Well, in MongoDB, you actually don't have that. You actually have one document object. So basically you have one object where instead of pointing to other tables that are within what you would call a table in that particular structure, you're just going to have the people objects be embedded in your MongoDB object instance. So it's a little bit different in that you're not pointing to these relational objects. I mean, it's all just within your MongoDB instance or your object. So MongoDB is very performant. However, a lot of the benchmarks are misleading. So everything I've seen to say that MongoDB is somehow magically faster than relational databases, the bottom line is that there's really no magic bullet. Just because some query performs better in some particular instance. A lot of that can be the way the code is written or the hardware on which the code is being executed. A lot of different things that would give you skewed results as to whether or not a typical relational database is faster or a NoSQL database like MongoDB is faster. So the bottom line is that they're both very performant. I just went ahead and mentioned that Mongo is performant here. Alright, now we're going to get into some of the bad of MongoDB. It cannot do SQL joins because there are no relational there's no relationships in MongoDB. So like typically when you do a SQL query, you can SQL data from multiple tables and then join all that data together into one object, and that's not something that MongoDB can do. You would actually have to do that manually and doing workarounds to be able to achieve a similar result. So a lot of people say you shouldn't be doing a lot of joins in MySQL anyway because they're not very performant, but the bottom line is you can't do it in MongoDB. So I'm not a database expert, but that's definitely a downside that I hear from MongoDB. Data design needs to be thought out well since it's not relational, meaning that you can't just add an additional table and then point to that using relationships in a typical relational database, or like you could in a typical relational database. In MongoDB, you really need to think out how these embedded objects are going to work and try to get all of that resolved while you're designing your database. So if you know that you're going to have a band object and the band's going to have multiple people embedded within it, you need to make sure that you don't want to eventually just add a new record label object, and otherwise you could run into some problems. So basically, it's a downside that you're supposed to be able to try to make sure that you're not going to be having to change your MongoDB database structure a whole lot after you go ahead and think it out initially. This is one of the big things that MongoDB is not good for, is ACID transactions. So ACID stands for atomicity, consistency, isolation, and durability. And basically it's a set of properties that guarantee a database transaction is either going to go through fully or it's not going to try to execute at all. So basically if anything fails and sort of like if you're updating several areas and one area fails, the entire transaction will be rolled back and fail in a normal ACID safe relational database structure. In MongoDB it doesn't do that. So you can have partial updates, run into some sort of error, and then your database could be fouled up to an extent. So you could have like an insert that you did and only half of it got inserted, so essentially you lost the other half of data, and you have bad data in there because you only updated half of the query and you never failed. Like in a normal relational database that's ACID safe, it would go ahead and update, run the fail, and then just retract itself, and that database entry wouldn't be there. So it's really bad that you can end up having a messed up database. And that also goes into the next part here, is that MongoDB has been known to have lost information. So you want to back up your database often, like literally, like you could do a transaction, and from what I hear, half that data could just just disappear in the process. So it's not really proven or anything like that, as far as I know. But there's just bugs that are reported where apparently the data is not 100% safe at all times. So if you do complicated transactions, you could run into a problem where your database is just not, or your data is not there like it should be. So that being said, just make sure you're backing up your data often if you're using MongoDB. So really, guys, that's really all the pros and cons that I can think of with MongoDB. There's not a whole lot of alternatives if you want to stick in the JavaScript world. Something that's good with Node.js. MongoDB is definitely like a partner with Node. It's part of the mean stack, which it's a Node, Express, Mongo, and Angular. And it's definitely getting a lot more corporate support as of late. It's getting a lot more money. It's actually starting to find ways of being able to make money to try to keep it around for longevity. There's a few other NoSQL alternatives out there, but none of them are, or many of them are actually much more complicated than what MongoDB would be. And ultimately, it's going to get better as time goes on, and it's still a relatively futuristic set of technology. So if you want to be in the here and now, it's probably a good idea to use MongoDB. If you want to be a little bit more safe, or if you're building some sort of financial transaction, or some important data like real-time analysis and things like that, you may want to stick with a traditional relational database. And as far as the sharding capabilities between either a relational database like MySQL or using MongoDB, a lot of companies, a lot of simple websites are never going to have to run into any sort of scalability issues like that. But if you are looking to be big, you can succeed using both, but you might have an easier time as a smaller operation using something like MongoDB than trying to get database experts involved in clustering and sharding a relational MySQL setup. Alright guys, thanks for watching. Have a good day. Please subscribe and vote up the video if you could, please. Thank you. Bye.
Okay, so I hope you all understood what MongoDB is. So if you have any questions, feel free to contact me anytime. Thank you so much.